we are going to start with exercise 6E of the chapter Simultaneous Linear Equation. And let's start with question number 1. Here we are having the ratio of the two numbers is 2 by 3 if 2 is subtracted from the first and 8 is subtracted from second. The ratio becomes the reciprocal of the original ratio. Find the numbers. Now let the numbers be x and y. In the very first equation, it is given that the ratio of these two numbers is 2:3. So it will be x upon y equals to 2 upon 3. Now we can do the cross multiplication and we get 3x equals to 2y as your first equation. And in the second equation we have 2 is subtracted from the first, that is x minus 2, and 8 from the second, that is y minus 8, and this is equals to the reciprocal of the previous ratio, that is 3 upon 2. Now we are going to do the cross multiplication, and in doing so we get 2 into x minus 2 equals to 3 into y minus 8. Now open the bracket and this will be 2x minus 4 equals to 3y minus 24. Now rearrange it and this will become 2x minus 3y equals to minus 20 as your second equation. Now we can take the value of x or y from here and place over here to get the answer. So let's from equation 1, x will be equals to 2 upon 3 y. Let this one be the third equation and place the value of this in equation number 2. So placing the value of x in equation number 2, we get 2 into 2 upon 3y minus 3y equals to minus 20. Now take the LCM, we get 3 as the LCM. This will be 4y minus 9y equals to minus 20, and here this is minus 5y upon 3 equals to minus 20. So the y equals to minus 20 into 3 upon minus 5. This is cancelled out and we get 4, that is y equals to 12. Now we can place the value of y in the third equation to get the value of x, and placing the value of y in equation number 3, we get x equals to 2 upon 3 into 12, that is 4. 2 into 4, that is 8. So the numbers are 8 and 12. Now let's see question number 2. Here we are having the two numbers and a ratio 4:7. If thrice the larger is added to twice the smaller, the sum is 59. Find the number. Now here again let the numbers be x and y, and as the numbers are in the ratio of 4:7, so x upon y equals to 4 upon 7, and this can be written as 7x equals to 4y, as this is your first equation. Now for the second equation we have to add thrice the larger to this twice the smaller, and the sum is 59. Here we can see this is x upon y, that is 4 upon 7. 7 is greater, this means this y will be greater. So 3 times of this y is added to 2 times of the x, and the sum is 59. This is your second equation. Now we can take the value of x or y from the first equation and put it in the second equation to get the value of the other one. So let's start from the first equation. So from equation 1, we can get the value of x as 4 upon 7y, and let this one be the third equation. Now place the value of x in equation number 2. So putting the value of x in equation number 2, we get 3y plus 2 into 4 upon 7y equals to 59. Now we're going to take the LCM of these two, and on doing so we get 7 over here, and 3 into 7, that is 21, y plus 8y equals to 59. Then 21 and 8, this will become 29. Y equals to 59 into 7. Now place the value of y over there, and this will become 413 upon 29. Now placing the value of y in equation number 3, we get x equals to 4 upon 7 into 413 upon 29. Now 7, 5s are 35 and 63, that is 9 times, and this will be equals to 236 upon 29 as answer. So numbers are 236 upon 29 and 413 upon 29. Now let's do question number 3. Here in this question we are having, when the greater of the two numbers increased by 1 divides the sum of the numbers, the result is 3 upon 2. When the difference of these numbers is divided by the smaller, the result is 1 by 2. Find the numbers. Let the numbers be x and y. Now according to the first equation, here it is the greater of two numbers. Let this x be the greater, so we have taken this x as greater, increased by 1, divides the sum. So x plus y is divided by x plus 1, and that gives this result as 3 by 2. Now to get the equation, we do the cross multiplication, and here 2x plus y equals to 3x plus 1. Now open the brackets, and here it will be 2x plus 2y equals to 3x plus 3. Now इसको rearrange करेंगे हम लोग, and this will become 2y minus x equals to 3 as first equation. Now by the second equation we are having the difference of the two numbers divided by the smaller number. We have taken this x as greater, so y is smaller one. So the difference is divided by smaller to get 1 by 2 as answer. Now to get the equation, we will do the cross multiplication, and here it will be 2x minus y equals to y. Then open the bracket, and it will be 2x minus 2y equals to y, and finally will be 2x equals to 3y as your second equation. Now we have to solve this two simultaneously. Let's take the first equation and find the value of x and put it over here. So from equation number 1, we can get the value of x as 2y minus 3, and let this one be the third equation. Now place this value of x over here. Now putting the value of x in equation number 2, we get 2 into 2y minus 3 equals to 3y. Now open the bracket, this will be 4y minus 6 equals to 3y, and on solving it, put this over here, so this will become y equals to 6 as the value of y. Now put the value of y in equation number 3. So putting the value of y in equation number 3, we get x equals to 2 into 6 minus 3, that is x equals to 12 minus 3, so x equals to 9. So numbers are 9 and 6. Now let's go with question number 4, and here we are having the sum of two positive integers, that is x and y, is 50, and the difference of their squares is 720. Find the number. Here it is given the sum of these two numbers is 50, so x plus y equals to 50. This is your first equation. Then the difference of their squares is 720. Now as it is x square minus y square, this can be written as x plus y and x minus y, that is equals to 720. Now we can place the value of x plus y over here, and this will become 50x minus y equals to 720. Now x minus y will be equals to 720 upon 50, cancel it out, and you will be getting x minus y equals to 14.4 as your second equation. Now we can solve them simultaneously, as y is having positive and negative sign over here. So we can add these two to get the value of x. So adding equation 1 and 2, we get x plus y equals to 50 and x minus y equals to 14.4. Now adding these two, we cancel out this one. This will become 2x equals to 64.4 and x will be equals to 32.2. Now place the value of x in any of the equation. So placing the value of x in equation number 1, we get 32.2 plus y equals to 50. So y equals to 50 minus 32.2. That is y equals to 17.8 as answer. So required numbers are 32.2 and 17.8. Now let's go with question number 5. Here the sum of two numbers is 8 and the sum of their reciprocals is 8 by 50. Find the numbers. Now let the numbers be x and y, as the sum is 8. So this will become x plus y equals to 8. And for the second equation, the sum of their reciprocals is 8 by 50. Here this is your first equation. And to get the second equation, here take the LCM of these two, and this will become xy, x plus y equals to 8 by 50. Now here we can place the value of xy over here. That is 8 upon x, y equals to 8 upon 50. Now this numerator to the numerator can be cancelled out, and this will become x, y equals to 15. And we can find the value of x from here as 15 upon y. And this is your second equation 2. Now place this value of x in the equation number 1. So putting the value of x in equation number 1, we get 15 upon y plus y equals to 8. Now multiply the whole equation by y, we get 15 plus y square equals to 8y. And on rearranging it on one side, this will become y square minus 8y plus 15 equals to 0. Now we have to factorize this, and on factorization we get 5 and 3. 5 into 3 is 15 and 5 plus 3 is 8. So we can write this one as y square minus 5y and minus 3y plus 15 equals to 0. Now the y minus 5 and here minus 3. So y minus 5 again equals to 0. So y minus 5 and y minus 3. Now we get the value of y as y minus 5 equals to 0, y minus 5 equals to 0 and y minus 3 equals to 0. So y equals to 5 and here y equals to 3. Then if y equals to 5, value of y in equation number 2, we get x as 15 upon 5, that is x equals to 3. And here we get the value of x as 3 and y as 5. And if we place this value, that is x equals to 15 upon 3, then we get x equals to 5. So if we take the value of y equals to 3, we get the value of x as 5. And if we take the value of y as 5, we get x as 3. Now let's go with question number 6. And here we are having the difference between the two positive numbers x and y is 4. And the difference of their reciprocals is 4 by 21. Find the number. Let the numbers be x and y. So the first equation, as the difference is 4, so we can write this one as x minus y equals to 4. And here we get the first equation. Now for the second equation, we are having the difference of the reciprocals as 4 upon 21. As the difference is positive, this means this will be written as 1 upon y minus 1 upon x equals to 4 upon 21. यहाँ पर ये नंबर बड़ा है, ये नंबर छोटा है। अगर हम बड़े नंबर का रेसिप्रोकल करेंगे तो वो हमारे पास छोटा नंबर आता है. That's why we have written this first, then the reciprocal of this one. Now we are going to take the LCM of these two, and here we get xy over here, and this will be x minus y equals to 4 upon 21. Then we can place the value of x minus y from here, and this will be 4 upon xy equals to 4 upon 21. Now this 4 can be cancelled by this one, and this will become xy equals to 21. Now we can find the value of x from here, and this will become x equals to 21 upon y, and let this one be equation number 2. Now we can place the value of x in equation number 1. So placing the value of x in equation number 1, we get 21 upon y minus y equals to 4. Now we can multiply the whole equation by y, and this will become 21 minus y square equals to 4y. Now on rearranging, we get y square plus 4y minus 21 equals to 0. Now the factors of 21 are 7 and 3. So this can be written as y square plus 7y minus 3y minus 21 equals to 0. Now we can take y common from here, and this will become y plus 7 minus 3 from here. So y plus 7 again equals to 0. So y minus y plus 7 and y minus 3 equals to 0. Now we can get the value of two values of y as y plus 7 equals to 0 and y minus 3 equals to 0. So y equals to minus 7 and y equals to 3 from here. As the required numbers is positive, so this is not taken, and we'll focus on this one only. And when we place the value of y equals to 3 in equation number 2, we get x equals to 21 upon 3. That is x equals to 7 as answer. Now let's go with question number 7. And here we are having the two numbers are in the ratio of 4:5. If 30 is subtracted from each of the numbers, the ratio becomes 1:2. Find the numbers. Now let the numbers be x and y, and here for the first equation, as they are in the ratio of 4:5, so this can be written as x upon y equals to 4 upon 5. And from here we can write this one as 5x equals to 4y. And this is your first equation. For the second one, it is given that if 30 subtracted from both of it, that is x minus 30 upon y minus 30, this becomes 1 upon 2. Now do the cross multiplication, and this will be 2x minus 60 equals to y minus 30, and it will be 2x minus y equals to 30. Let's also find the value of y from here, and it will become y equals to 2x minus 30. That is your second equation. Now place this value of y in equation number first, and on placing the value of y in equation number 1, we get 5x equals to 4 into 2x minus 30. Now solve it. So 5x equals to 8x minus 120. Now make a transformation, and 8 minus 5, that is 3x equals to 120. This is sent over here, and on solving we get x equals to 40. On placing the value of x in equation number 2, we get y equals to 2 into 40 minus 30. That is y equals to 80 minus 30, and y will be 50 as answer. Now let's go with question number 8. And here we are having the numerator of the fraction is increased by 2 and the denominator is decreased by 1. It becomes 2 by 3. If the numerator is increased by 1 and denominator is increased by 2, it becomes 1 by 3. Find the fraction. Now let numerator be x and the denominator be y. And on doing so, the fraction becomes x upon y. Now, for the first equation, it is saying that the numerator of a fraction is increased by 2, that is x plus 2, and the denominator is decreased by 1. So, y minus 1. And this becomes 2 by 3. On making a cross multiplication, we get 3 into x plus 2 equals to 2 into y minus 1, and it will be 3x plus 6 equals to 2y minus 2. Now make a transpose, and this will become 3x minus 2y equals to minus 8 as the first equation. And for the second equation, we are having numerator is increased by 1 and denominator is increased by 2, and the fraction becomes 1 by 3. Again, we are going to do the cross multiplication. On doing so, this will be 3 into x plus 1 equals to y plus 2. Now open the bracket, and it will be 3x plus 3 equals to y plus 2. And on making the transpose, this will be 3x minus y equals to minus 1 as your second equation. Now we have to solve these two equations simultaneously. Here we see this one is 3x, this is also 3x. So we can directly subtract these two. So subtracting equation 2 from equation 1, we get, then we are going to change the sign, and here we get minus, this one is positive, and this is also positive. Here we solve it, and minus and plus, and this will be minus y equals to minus 7. So y equals to 7. Then place the value of y in any of the equation. So placing the value of y in equation number 2, we get 3x minus 7 equals to minus 1. That is 3x equals to 6, and here it will be x equals to 2. So required fraction is x upon y, that is 2 upon 7 as answer. Now let's go with question number 9, and here we are having the sum of the numerator and the denominator of the fraction is equals to 7. 4 times the numerator is 8 less than 5 times the denominator. Find the fraction. Let the numerator be x and the denominator be y, and the required fraction will become x upon y. So for the first equation, we are having the sum of numerator and denominator as 7. So this will be x plus y equals to 7 as your first equation. Now for the second one, 4 times the numerator is 8 less than 5 times the denominator, that is 5y minus 4x equals to 8, and this is your second equation. Now we are going to equate the coefficient of either x or y. So if we equate the coefficient of y, we have to multiply this whole equation by 5. So multiply equation 1 by 5 and equation 2 by 1, and we get 5y plus 5x equals to 35, and this will be 5y minus 4x equals to 8. Then change the signs, and this will be minus plus minus, and here we get 5 plus this, that is 9x equals to 27, and x will be equals to 3. Now place the value of x in equation number 1. So placing the value of x in equation number 1, we get 3 plus y equals to 7, that is y equals to 4. So required fraction is x upon y, that is 3 upon 4 as answer. Now let's go with question number 10. Here we are having, if the numerator of fraction is multiplied by 2 and its denominator is increased by 1, it becomes 1. However, if the numerator is increased by 4 and the denominator is multiplied by 2, the fraction becomes 1 by 2. Find the fraction. Here, let the numerator be x and the denominator be y, and then the fraction becomes x upon y. So for the first equation, it has been given that numerator of the fraction is multiplied by 2, that is 2x, and denominator is increased by 1, that is y plus 1. It becomes 1. So here it is equals to 1. Now do the cross multiplication, and doing so this will be 2x equals to y plus 1, and from here only we can find the value of y, and this will be y equals to 2x minus 1. That is your first equation. Now for the second equation, it has been given if the numerator is increased by 4, that is x plus 4 upon denominator is multiplied by 2, that is 2y, this becomes 1 by 2, and here we get 1 by 2. Again we are going to do the cross multiplication, and this will become 2x plus 8 equals to 2y, and if we place the value of y over here, we get 2x plus 8 equals to 2 into 2x minus 1, and on opening the bracket, 2x plus 8 equals to 4x minus 2. Now on shifting, we get 8 plus 2 equals to 4x minus 2x, and hence it will be 2x equals to 10 and x equals to 5. Now we can place the value of x in equation number 1. So placing the value of x in equation number 1, we get y equals to 2 into 5 minus 1, that is y equals to 10 minus 1, that is 9. So required fraction is 5 upon 9 as answer. Now let's go with question number 11, and here it is. The fraction becomes 1 by 2 if 5 is subtracted from its numerator and 3 is subtracted from its denominator. If denominator of this fraction is 5 more than its numerator, find the fraction. Let the numerator be x and the denominator be y, and the required fraction will become x upon y. Then here it has been given the fraction becomes 1 by 2, that is it is equals to 1 upon 2 when 5 is subtracted from its numerator, that is x minus 5, and 3 subtracted from its denominator, that is y minus 3. Here we get the relation of the first equation, and on doing the cross multiplication, we get 2x minus 10 equals to y minus 3. And here on rearranging, we get y equals to 2x minus 7. And this is your first equation. Now for the second equation, we are having the denominator of this fraction is 5 more than its numerator, that is y minus x equals to 5. And this is your second equation. Here we can place the value of y from first equation to this, and this will become 2x minus 7 minus x equals to 5. And on solving it, this will become x equals to 12. Then place the value of x in equation number 1. So placing the value of x in equation number 1, we get y equals to 2 into 12 minus 7, that is y equals to 24 minus 7, that is y equals to 70. So required fraction is 12 upon 70, that is 12 upon 17 as answer. Now let's go with question number 12. Here the sum of the digits of the two-digit number is 5. If the digits are reversed, the number is reduced by 27. Find the numbers. Now जब भी हमें ये क्वेश्चन मिलता है, इनमें सबसे पहले हम लोग यूनिट डिजिट को एक x, टेंथ डिजिट को y, फिर ओरिजिनल नंबर दैट इज 10y प्लस x, और इसका रिवर्स दैट इज 10x प्लस y, हम लोग इतना अज्यूम करने के बाद हम लोग क्वेश्चन में एंटर करते हैं, एंड हियर इट इज बीन गिवन दैट The sum of the digits of the two-digit number is 5. So the first equation will be x plus y equals to 5. Now for the second equation, if the digits are reversed, the number is reduced by 27. That is, the difference of these two is 27, in which the original number is greater. So this will be 10y plus x minus 10x plus y equals to 27. Now solve it, and here it will be 10y plus x minus 10x minus y equals to 27. Here we can solve this. So it will be 10y minus y, that is 9y minus 9x equals to 27. Now here this whole equation can be divided by 9 and we get y minus x equals to 3 as the second equation. Now here we can see this one is x plus y, this one is y minus x. So we can add these two to get the value of x or y. So adding equation 1 and 2, we get x plus y equals to 5 and minus x plus y equals to 3. This will be cancelled out. So 2y equals to 8 and y equals to 4. Then place the value of y in any of the equation. So placing the value of y in equation number 1, we get x plus 4 equals to 5 and here we get x equals to 1. So original number equals to 10y plus x, that is 10 into 4 plus 1, that is 41 as answer. Now let's go with question number 13. The sum of the digits of the two-digit number is 7. If the digits are reversed, the new number is decreased by 2 equals to twice the original number. Find the number. Now let the unit digit be x and the tens digit be y. The original number will be again 10y plus x and the reverse number will be 10x plus y. For the first equation we are having the sum of the digits is 7. So x plus y equals to 7. That is your first equation. And for the second equation, it has been given that if the digits are reversed, the new number decreased by 2. Reverse number, that is this one, that 10x plus y, and decreased by 2 minus 2 equals to twice the original number. That is 2 into 10y plus x. Now we are going to solve it and this will become 10x plus y minus 2 equals to 20y plus 2x. Now make a transpose and this will be 10x plus y minus 20y minus 2x equals to 2. Now solve these two and here it will be 8x minus 19y equals to 2 as your second equation. Now from the first equation we can find the value of x and place over here to get the value of y. So from equation 1, the value of x will be 7 minus y. That is your third equation. Now placing the value of x in equation number 2, we get 8 7 minus y minus 19y equals to 2. Now open the bracket. 7 into 8, that is 56 minus 8y minus 19y equals to 2. Now solve it. Send this over here and the sum of these two on the other side, that is 56 minus 2, that is 54 equals to 19 plus this, that is 27y. That implies y equals to 2. Now place the value of y in equation number 3. On placing the value of y in equation number 3, we get x equals to 7 minus 2. That is x equals to 5. So original number equals to 10 into y, that is 2 plus 5, that is 25 as answer. Now let's go with question number 14. Here it is. The tens digit of the two-digit number is 3 times the unit digit. The sum of the numbers and its unit digit is 32. Find the numbers. Let the unit digit be x and the tens digit be y. So the original number is 10y plus x. Now for the first equation, the tens digit of the two-digit number is 3 times the unit digit. That is y equals to 3x. And this is your first equation. And the second equation will be the sum of number and the unit digit is 32. So here it is 10y plus x equals to 32. The number and the unit digit equals to 32. Now we can solve this one, that is 10y plus 2x equals to 32. And here we can divide the whole equation by 2 and we get 5y plus x equals to 16. That is your second equation. Now we can place the value of y from the equation number 1 in the equation number 2 and we get 5 into 3x plus x equals to 16. Now open the bracket and here it will be 15x plus x equals to 16. So 16x equals to 16 and x equals to 1. Now place the value of x in equation number 1. On placing the value of x in equation number 1, we get y equals to 3 into 1. That is y equals to 3. So original number is 10y plus x, that is 10 into 3 plus 1, that is 31 as answer. Now we're going with question number 15. A two-digit number is such that the tens digit exceeds twice the unit digit by 2 and the number obtained by interchanging the digit is 5 more than 3 times the sum of the digits. Find the two-digit number. So here let the unit digit be x and the tens digit be y. And with these two, the original number is 10y plus x and the reverse number will be 10x plus y, which is obtained by interchanging the digits. Now for the first equation, we are having the tens digit exceeds twice the unit digit by 2. So y minus 2x equals to 2. And here we get the first equation. Then, and the number obtained by interchanging the digits, 5 more than, that is 5 plus 3 times the sum, that is 3x plus y. Now solve it, and on solving we get 10x plus y equals to 5 plus 3x plus 3y. Now put all the variables on this side and this will become 10x plus y minus 3x and minus 3y equals to 5. And here it will be 7x minus 2y equals to 5. And this is your second equation. Now we can find the value of y from the first equation and put it over here. So from equation 1, y equals to 2x plus 2. That this one will be the third equation. Now putting the value of y in equation number 2, we get 7x minus 2x plus 2 equals to 5. And here we are having 7x minus 4x minus 4 equals to 5. 7 minus 4, that is 3x equals to 9. And here x will be equals to 3. Now place the value of x in equation number 3. So on placing value of x in equation number 3, we get y equals to 2 into 3 plus 2. That is y equals to 6 plus 2, that is 8. So original number equals to 10 into y, that is 8, plus x, that is 3. So it is 83 as answer. Now let's go with question number 16. And here we are having 4 times the certain two-digit number is 7 times the number obtained by interchanging its digits. If the difference between the digits is 4, find the number. Let the unit digit be x, tens digit be y, and the original number we get 10y plus x and the reverse number is 10x plus y. Now for the first equation we are having 4 times the certain two-digit number, that is 4 times of this one, 4 into 10y plus x. 7 times the number obtained by interchanging its digits. So this is equals to 7 10x plus y. Now open the brackets and solve it, and this will be 40y plus 4x equals to 70x plus 7y. Now rearrange them, and here it will be 40y minus 7y equals to 70x minus 4x. And here on solving, this will be 33y equals to 66x, and on dividing both sides by 33 we get y equals to 2x. And here we get the first equation, and then for second equation we are having y minus x equals to 4 as your second equation. Now here we are having y equals to 2x, so we can place the value over there, and we get 2x minus x equals to 4, and x will be equals to 4. Then placing the value of x in equation number 1, we get y equals to 2 into 4, that is y equals to 8. Then we are going to place these two values in the original number. So original number is 10 into 8 plus 4, that is 84 as answer. Now let's go with question number 70. Here we are having the sum of the two-digit number and the number obtained by interchanging the digits of the number is 121. If the digits of the number differ by 3, find the number. The digit be x and the tens digit be y. So the original number is 10y plus x and the reverse number is 10x plus y. So the first equation we get is this number. The sum of these two is 121, that is 10y plus x plus 10x plus y equals to 121, and here it will be 11x plus 11y equals to 121. This whole equation can be divided by 11, and this will become x plus y equals to 11. That is your first equation. And for the second equation we are having the digits of the number differ by 3, that is x minus y equals to 3. This is your second equation. Now we can add both of the equation to get the value of x or y. So adding equation 1 and 2, we get x plus y equals to 11 and x minus y equals to 3. These two will be cancelled out, so 2x equals to 14 and x equals to 7. Now place the value of x in equation number 1 or 2. So placing the value of x in equation number 1, we get 7 plus y equals to 11. That is y equals to 4. So original number is equals to 10y plus x, that is 10 into 4 plus 7, that is 47 as answer. Now let's see question number 18, and here we are having a two-digit number is obtained by multiplying the sum of digits by 8. Also, it is obtained by multiplying the difference of the digits by 14 and adding 2. Find the number. Now let unit digit be x and the tens digit be y, and the original number obtained by these two is 10y plus x. Now for the first equation, it has been given that the original number, that is 10y plus x, can be obtained when the sum of digits, that is x plus y, is multiplied by 8. Now here we are going to solve it. So that is 10y plus x equals to 8x plus 8y. Now make a transpose and all. So this will become 10y minus 8y equals to 8x minus x. And here it will be 2y equals to 7x. And let this one be equation number 1. Now for the second equation we are having that we can obtain this number, that is 10y plus x, when the difference of these two is multiplied by 14. And for the difference, we have to choose which one is greater, which one is smaller. As we see, that is 2y is equals to 7x. मतलब छोटे नंबर से मल्टीप्लाई कर रहे हैं y के, तो भी वो बड़े नंबर से मल्टीप्लाई करने वाले x के बराबर हो रहा है. This means this one is greater and this one is smaller. So 14y minus x, and we have to add 2 also to equate it. Done. Open the bracket and solve it. So 10y plus x equals to 14y minus 14x plus 2. Then put all the variable on this side, and this will be 10y plus x minus 14y plus 14x equals to 2. Now we are going to solve it, and we get 15x minus 10y minus 14, that is 4y equals to 2 as second equation. Now from equation number 1, we can find the value of y as 7 upon 2x, and let this one be equation number 3. Now putting the value of y in equation number 2, we get 15x minus 4 into 7 upon 2x equals to 2. Here we are going to solve it to get 15x minus 14x equals to 2, that is x equals to 2. Now place the value of 2 in equation number 3. And here, on placing the value of x in equation number 3, we get y equals to 7 upon 2 into 2. It is cancelled out, and here we get y equals to 7. So original number equals to 10 into 7 plus 2, that is 72 as answer. That's all in this video. Thank you.